Welcome back, guys. My name is DrAvitech, and in this video, we're going to be solving this very problem on gamma functions. Remember to hit the subscribe button, like this video, and share it across to your classmates. So, we're asked to find that integral, evaluate that integral. Now, earlier on, I've specified that there's a particular way, there's a standard way that all gamma functions should look like, and this is it. Now, it's not that bulky. The only thing you need to always remember is your exponential must have a negative x, or should have just the negative single function. Should I call it negative single function? What I mean is the x should not have a coefficient. That's what I'm trying to say. The x should not have a coefficient. So this x you see here shouldn't have a coefficient. That's what I'm trying to say. But currently, as you can see, it has a 4. So the minus is a constant. It's the minus that's the 4 that's a problem. So we're going to say let's that very 4x become something else. So we need to just be a single item. So I want to say let u equal to 4x. So it becomes just a single thing at the top. So if u is equal to 4x, this tells me that to make s a subject, I need to divide both sides by 4. So this is u over 4 is equal to x. Now, ideally, please take note that whenever you make a substitution, every other thing about that integral is going to change. Since you are saying let u become 4x, it means every single thing that has x will become u. That's the meaning. So every single s will go away and u would be left. That's the meaning. Now, we've been able to say let u be 4x and let u over 4 be x. But we've not yet gotten dx. Now, how do we get dx? We simply differentiate. That's what we do. We differentiate. So if u is equal to 4x and u over 4 is equal to x, let's differentiate. You could differentiate any of the two. But if you differentiate the second one, you're going to have your answer directly. But let me differentiate this one since it might be easy for starters. So I'm going to say du. So du is equal to 4x. So that's just going to be 4, because if we differentiate 4x, you're just going to have 4 dx. So this is what you're going to be getting. That's what you're going to be getting. Now, you want to make ds the subject, so you have to divide both sides by 4. So this is du divided by 4 equal to dx. And currently, you have everything you need. So you need this guy, you need this, and you need this. So now, let's make our substitution. So we have the integral from 0 to infinity. Now, in this case, our limit is not going to change. Our limit is going to remain the same. So let's start. X, what is x? X is u over 4. So anywhere I see x, I'm going to put u. So this is u over 4. U over 4. Everything is raised to the power of 3. Then this is e to minus 4x is u. So this is u. And then dx is du over 4. Du over 4. So the main idea is every single thing that has x should go away and only u should remain. So that's what just happened. There's no s anymore. All of the x's are gone. You just the one remaining. U is the one left. So this is the integral from 0 to infinity. Now let's bring this item. Let's simplify this. So this will be u cubed divided by 4 cubed is 64. So this is 64. And we have e to negative u du over 4. Now, these two guys are denominators, so they can multiply each other and come outside since they're constants. 64 times 4 is 256. So this is 1 divided by 256. And then the integral is from 0 to infinity of what will be left becomes the numerator. U cubed e to negative u du. This guy is 24. Yeah. Okay. So this is 1 divided by 256 times. Now let's just write this in terms of factorial. Remember that this whole expression here is just going to be 3 factorial. In earlier videos, I've explained how this happens. So this will just be 3 factorial. Now this is 1 divided by 256 multiplied by 3 factorial is 6. Or you could say 3 times 2 times 1. Now 2 can go into 2, that gives us 1. 2 into 2, 5, 6 is 128. So the final result to then become 3 divided by 128. Remember to hit the subscribe button, like this video, and share it across to your classmates. This will be all for the solution of this very problem. And that's how we solve using the gamma function. So let's go to the next video.